this. So look, 70, 90, 10, just go ahead and convert it to radians or degrees, depending what it is they're wanting to give you. Okay? Okay, look. State if the given angles are coterminal. Okay, so look. They're giving you 185 degrees, right? Okay, so 185 degrees. Look, if they're not making you do... Okay, they need to shut their door if they're going to be that loud. For 105 degrees, this is 180, so 185 is right here. Okay, for it to be coterminal, it has to land on that terminal side. Okay? Well, wouldn't you shut your door if you know you're making that much noise?
Tell them they're walking in. They're walking in.
Okay, negative 545 though. Right? Okay, negative 545 is, okay, so if I negative 545, so here's, okay, this is negative 360, right? But we want another 360, so what's 545 minus 360 gives me another 185. Okay, this is negative 545. So, for some of you, the visual helps, right? Because remember, like I said, kind of American life, yes, you guys, you know, X Games, if you're in ballet or any kind of spinning, skateboarding, you know, biking, whatever, you have your 540s, you know, 1080s, 360s, right, 270s. You guys know those are your spins or your revolutions, or a spin and a half, okay? So you may understand degrees, but we really don't talk about negative degrees, and so your negative angle of rotation is starting off at 0, but you're going quadrant 4, 3, 2, 1. So obviously if you're on a calculator, if I show you, this came up to 185 degrees. So you may say, oh, it's the same, 185, 185. No, big no, because this is a positive angle of rotation, meaning you're starting at the 0 degrees and you're moving quadrant 1, 2, 3, and you're stopping at 185 degrees. But this negative 545 is a negative angle of rotation. So you're starting at 0 degrees, but you're going quadrant 3, 2, 1, and then around again, and your negative 185 is here. So it's not the same location because of your angle rotation. If they gave you 185 and positive 45, then they would be coterminal. But because one's positive, one negative, it's opening up differently. So it's a no. It's a big no. Okay, find a coterminal angle between 0 and 360. Okay, so for those of you that need to draw it, and by the way, you don't have to, but it does help spatially for you to understand it. Negative 330 means I'm opening up quadrant 4, 3, 2, 1, right? So if I know 360 is one full revolution, then that means negative 330 kind of has a 30 degrees, right? Negative 330, so negative 30 would be here, right? Because that makes 360. Okay, so if it says find a coterminal angle between 0 and 360, here, let me put the terminal side. Then that would make it, if I was to draw it positively, then if I was to open up in a positive, it would be plus 30 degrees, right? Negative 30 degrees is the same as positive 30 degrees. That's the same rotation. On day 1 and day 2, sometimes you guys are like, I I guess. I'm getting the conversion. But once you start drawing it enough, you're like, okay, I see what quadrant I'm landing on. Oh, so positive is 1, 2, 3, 4, negative is 4, 3, 2, 1.
This kid on the quiz is like, you said 245.
You'll see. Hold on. Okay, all right, next. 17, find a coterminal angle between 0 and 2 pi. That means I want 1 spin or 1 revolution, depending, whatever word works for you. There's synonyms. 1 spins or 1 revolution. Okay, look, 11 pi over 3. You guys have to understand 2 pi is 1 revolution, which is like 360 degrees. Okay, but we want pi. All right, so without doing this, look, you guys have to kind of see 11 pi over 3 is equivalent to, okay, do you guys understand that, what could I write on? Okay. Okay, 3 pi over 3 is 1 pi. Do you guys agree with that? So then 6 pi over 3 is 2 pi. Do you guys agree with that? Yeah? Kind of, do you guys understand denominators is what I'm getting at? Okay, so what you guys have to see is 6 pi over 3 and 5 pi over 3 is equivalent to 11 pi over 3. Right? Because if you have the same denominator, then that means you just add or subtract your numerators. So 6 plus 5 is 11, right? So, were you here 2 days ago? You've been absent for 2 days? Really? Okay, so if I want 11 pi over 3 is 11 pi over 3 is 2 revolutions, right? Because look, this is 1 complete 2 pi. So this is a second revolution because these are 2, this is 2 revolutions, 2 spins. I'll do it, I'll take it to degrees in a second. This is a second revolution. This is the first revolution. So if I want a coterminal angle between 0 to 2 pi, this is your answer. Okay, if that makes sense to you, remember, you guys are working with fractions and denominators, so some of you cue in on this stuff. It makes sense to you? Okay, so let's go to degrees if you guys don't understand that. Okay, 11 pi over 3. Transfer that to a degree. And I get, let me make sure you can see it. Yeah, 11 pi over 3 times 180. Wait, whoopsie. Pi, and I get 660, right? Okay, this is equivalent to 660 degrees. All right, if I do the visual, this is 360. But I want 660. So I'm going to go another 300 degrees. And this is my 300 degrees. Or it's equivalent to 11, well, 660. Or 660 degrees, right? Okay, so take 300 degrees and transfer that. Oopsie. And I get 5 pi over 3. And so 5 pi over 3, and there's my 5 pi over 3. So, you're totally welcome to transfer everything to degrees, work off the 360, find your coterminal, and then afterwards transfer it or convert it right back to radians. Or, if you guys understand fractions and you understand numerator-denominator relationships, if the denominator is 3, then that means 3 over 3 is 1. What's 6 over 3? 2. So 6 over 3, 6 pi over 3 is a 1 full spin. It's 2 pi. So that's 1 spin. What's then the coterminal? Well, I need to make 11, so I need 5 more to equate it. That's your coterminal angle. Because you guys are dealing with multiples and spins, you guys can, there's kind of different ways of doing it. You just have to decide what makes sense in your head. If you don't like what I did, that's fine. Okay, if you don't like, you gotta know your noisy, right? It's like, whatever. Okay, anyways, there you go. Fair enough, I'll be quiet. Try it, take it to degrees and give it a go. Oh, let me see it. I'll go over there and look.